Okay, check out this sweet little backhoe that I purchased for my skid steer. This is going to be very useful in my current project. I ran a couple hours out of town, one state away, to scoop this guy up. I'm excited because it's John Deere. My machine's John Deere. It had what looked like the same kind of mechanical attachment. This was before they standardized skid steer attachment, so I went all the way down there, and it is the same style. In fact, the hook, it's kind of buried in the dirt here. It's a French cleat, so this is a 45-degree angle underneath there, and that hangs on the plate for the machine, which bears the weight, and that, you know, it's 45-degree negative, and this is a 45-degree positive, so it hangs on there, fits tightly, and the surface runs down that surface. This should be tipped up normal. You can see how extended that is. But that bears the weight and provides a lot of surface area, and then you throw these levers, and a little bar sits into this hook, and then a cam pushes him down, so it pushes down, it pulls everything together tightly, and that's how you quick attach and unattach. I got several attachments with this machine. I got a snow plow there, I got a set of forks, and a bucket. The bucket's the only thing that's OEM or manufacturer fabricated, whatever. They made it real pretty. They made it real pretty and relatively complex. You notice the sides flare out a little bit to help you lead you in. This is a 45-degree negative underneath here, and then here's those hooks. This is a better look. So it's the same style. The hook is the same, but mine's a bigger format. They're wider from one another. They're higher. You know, it's a larger dimension to this. It won't work. I can't attach that to that, and I need to get to work. So I kind of used this for reference, and I have a set of forks too, that the plow and the forks have just got this farmer fabrication, I would call it, like a weird little pin that you throw in. They're not real secure. They're from something else. It's not a 45-degree angle cleat. It's just this U shape. So it hangs on my machine just fine, but I think what I want to do is make an adapter plate that'll go right onto the backhoe, and if it's cheap enough, I'll make one or two more. I'll make one for the forks, and I'll make one for the plow. At least one for the forks if it's cheap enough to make one second one. But then I'll really have an arsenal of machinery here. And then I don't even think, I'm gonna maybe burn hooks. I'm gonna have all the pieces cut on a CNC table, so I'll show you what I'm doing with CAD in a second. But I'm gonna have to cut these off and take the end cap off, and then my plate will basically go in underneath this and be attached to this assembly permanently. So the ends will come off of this, but the 45 I make will go right into this 45 and make a new larger negative, and the hooks will be cut off so it'll fit in there, and then it'll hang on my machine, and I can put either those hooks back on, but I'll show you if I think I may just have new ones cut as well, so I have them if I want them, and if there's a problem getting the old ones cut off and reusing them, then there's no problem because I've made new ones. So this morning I'm still in my flippy floppies, but I gotta get the local gravel pit. A family friend that runs that. Come on, fucking horse shit. Trying to keep the cat inside. Where are you, cat? Anyway, I went out to get the hook geometry. The simplest thing to do sometimes is take a photograph if you can keep the lens distortion down, and then work with a photograph as an underlay in CAD. Or I knew this was farm equipment. It would be fairly rounded numbers, and it's not very precise. You know, we're not working to 10,000ths of an inch. I just did I justified the edge of this paper to the back surface of the bucket. Because there's a weld here I wanted to make sure to accommodate, and then I just pressed the paper around and got a template, measured it with the tape, and it was fairly straightforward, round numbers. And people, you know, may approach this incorrectly. I just noticed when I was doing this, there's a whole method to my madness here. But you know, this is the part that you want. But finding, people immediately when they see angles, they want to find angles. What's the angle? Yeah, you know, how you measure what this angle is here, and how do you measure what this angle is here? Forget it. This paper is normal to the back of the bucket, And obviously the back surface of this hook is parallel to the surface of the bucket. And obviously the top surface of the hook is perpendicular. This is a 90 degrees here, right hand corner. So all I started by doing is measuring from the surface to this corner is 3 inches, and then I want to know, and I did this on line paper, you could do it on graph paper, this is helpful, but I know this surface falls basically on this blue line, and I know that this corner comes in maybe a little heavy, but it's real close to this line, so if I move that down I can get a measurement from there to there, and that's about 3 inches. Now we're in a box. We have a 3-inch box. Then I can, I measured the length of this surface is 7/8 of an inch. So I put him there, and I measured the length of this surface, and I measure its distance from this surface right here, so you can get his length correct and his position from here. And the last things, you get these straight lines all in here first, 2, 3, and then in this point back here. But you have these two ends, then just connect them. I'll do that in CAD. I mean, this is the translation, so it has the line in there, and this has the line in there. But in CAD, I'll just make a 3-inch by 3-inch box, and then I'll put these two lengths in this corner, and I'll note this point here, and I'll pull this line in down to this length at this location from this line, and then I'll be left with just putting a line here, click, click, and it'll shoot into place, and I'll click, click, and it'll shoot into place there, and I'll have the hook in CAD. That's a nice way to do that. The rest of this system here, let me put this into a Autodesk Inventor before everybody comments, what software do you use? What software? It's Autodesk Inventor. It's a mechanical 3D program, very much like SolidWorks. But this is the idea of what we want to make. It's just a plate that hangs on my skid steer plate. You notice the ends are larger all the way around. I didn't make them fit inside. That turns into a pain in the ass to weld. I could have made the plate, the dimension inside here is a certain size. So if I made the end caps fit inside either direction, it makes that dimension smaller, so this overall plate would have had to have been longer. Okay, no problem. And then you make this perfect, the idea being you make this perfect shape that fits in there, where this plate passes and that butts inside, but then you have to weld it along the inside, which gets in the way. It rounds the inside corner out. You have to weld it around the outside, which is unhandy on an outside surface. You're just adding an ugly weld around the outside, and then there's no way to know when you take this plate and you bend it. They're going to put it in a device that, come on, there's a negative and a positive, like a paper cutter that's dull, and it's just going to push into that plate, and it's going to, from flat, it's going to go to 45 degrees. But it's very hard to dial in the exact radius and the lengths of these legs. It's kind of rough. So trying to make a piece that'll sit perfectly in there and be ready to weld is a fool's errand. So we've designed this with that in mind to the best of our ability. We don't do this full time, but I have worked in drafting and mechanical design for several years on several different occasions. We left it longer all the way around, and then it can be seal welded or stitch welded in that inside corner, no problem, and that weld isn't in anybody's way, and it's bigger all the way around, so we have room to put it on there and get it, so long as the plate is correct, then we can float that end on there until it's balanced all the way around and welded. It'll look very professional. We won't have to really, it's not aerospace here. So that's our intention. Then I had to figure, I didn't use the sheet metal tool in this, which will flatten something that you intend to bend and tell you what the overall size is. I did a little bit of just head scratching and worked. I basically measured both legs of that piece. Where's my cursor here? I just went into the sketch environment on, where is it? Here's the adapter plate. This is the drawing, excuse me. Where's the end cap? Here we go. You go into the end cap, and I can open up the sketch, and I just sort of measured this inside leg and that inside leg length and added them together. It was about 18 and 4, which is about a 22-inch piece, and that means the bend is right at about 4 inches. So now I've got a flat plate that's that size, and we'll cut a rectangle out, and then I'll just say 4 inches down will be where we'll put. It'll be marked with chalk. It's very rough, but this will be enough, and I'll get the drawing together to go down to the shop, so that I'm not a complete fool going in there talking about, I kind of want it like this and I kind of want it like that. No fabrication shop wants to hear that. Put it, even if it's a napkin sketch, even if it's something sketchy like this, draw it. So here's the 3 views. Some people can't use CAD, but if you're trying to make something custom and you can't even make a drafting, of various views of it and put dimensions on there, then you have no business. you have no business farting around with it to begin with. Anyway, so we're preparing this stuff here, and we're going to work off of this to draw up hooks, and we can make a, you know, there'll be a spot on the plate where we could just burn. I think it's 4 per unit, so we'll make 8. And then we have the 4 that we could cut off that plate. If we can reuse them, we can reuse them. If we can't, we can't. But there's probably no problem cutting them. It's just going to be getting right along the surface to cut them off. You always have, you know, the rest of the grinder or the cutting wheel arbor sticking off, and it steps your cutter down. You can't quite cut it flush, and then it's a bit too short, and then this is a little bit too small, and nothing works quite right. So I think the easiest thing to do is to start with a complete one, and we'll probably end up using the new ones. But I just wanted to cover this here. It took an hour or 2 to put this material together. Then we're going to take the CAD lines down on a thumb drive and CNC cut them on the plasma cutter. We'll show you that, and folded them on the brake. And we'll see how it turns out in the end. All right, stay tuned. Thanks for watching. We'll see you.